In this video, we will find quadratic equation from its graph. There are a number of different ways to do this problem, but I personally like to use the two equations that I wrote up in here. First one is y is equal to a times x minus p and x minus q. These are helpful when you know where the graph is passing through the x-axis. Second one is the vertex form, y is equal to a times x minus h squared plus k, where vertex is at h and k. Again, this one is helpful when you know the vertex. Let's look at the question A. We have a graph that has a y-intercept at 3, and it's passing the x-axis 3 and -1. So we know it has to be y is equal to a times x plus 1 and x minus 3. Because if I solve this for 0, x plus 1 is equal to 0, x is equal to -1. So think of this as sort of negating your zeros. X plus 1 gives you that answer of -1, x minus 3 gives you the answer of 3. So now we need to figure out the a. The point that we haven't worked with yet are this 3 y-intercept. So when x is 0, you get a y value of 3. So 3 is equal to a times, plug in 0 for x, so we have 1 and -3. So we basically have 3 is equal to -3a. Therefore, there's 3 dots, that means therefore a is equal to -1. So rewriting this quadratic equation, we have y is equal to negative x plus 1 and x minus 3. For the second problem, we are given a vertex 2. In other words, this has a coordinate of 2 and 0. 8 over here has a coordinate of 0 and 8. Since we know the vertex already, it might be easier to find the quadratic equations using a vertex form. We have y is equal to a times x minus 2, right? Negate that 0, squared, plus k, in this case, is a 0. So we'll leave it at that. We also know when x is equal to 0, y value is equal to 8. So 8 is equal to a times 0 minus 2, that's -2 squared. 8 therefore is equal to 4a, and again 3 dot, that means therefore a is equal to 2. So rewriting this equation, we have y is equal to 2 times x minus 2 squared. Find the quadratic equation given this graph. We are given -2 and some point over here as where it crosses the x-axis. So it has a coordinate of -2 and 0, and we don't know the x-coordinate, but we know the y-coordinate must be 0. We are also given 16 as a y-intercept. That means when x is equal to 0, y value is equal to 16. We're also given this dotted line, which is the axis of symmetry. That means when I fold this quadratics along this line, x is equal to 1, the -2 on the left side will match exactly onto the one I have circled over here. The distance between -2 to 1 is equal to 3 because -2, -1, 0, and 1. So that has a distance of 3. From 1 to this point that I have circled, the distance has to be 3 also. So that point must be 4. 3 more from 1. So now we can write this as a quadratic equation. Y is equal to a, x plus 2, and x minus 4. When x is equal to 0, y is equal to 16. So 16 is equal to a times 2 times -4. 16 is equal to -8 a. Therefore, a must be -2. The quadratic equation, therefore, will be y is equal to -2 times x plus 2 and x minus 4. Find the quadratic equation whose graph cuts the x-axis at 4 and -3, which also passes through a point at 2 and -20. Write in the form of y is equal to ax squared plus bx plus c. First, if we were to try to graph this to see what's happening, we are given that it cuts the x-axis at 4 and -3. So 4 and -3, it cuts the x-axis. It also passes through a point when it's 2, it's at -20, so somewhere over here. So this graph must be a concave down graph. We can rewrite this as a y is equal to a times x plus 3 and x minus 4. Plug in the values that we know. When x is equal to 2, y is equal to -20. So -20 is equal to a times 2 plus 3, that's 5, 2 minus 4, that's -2. So we have -20 is equal to -10a. Therefore, a must be equal to 2. Now that we have y is equal to 2 times x plus 3 times x minus 4, we want to rewrite this in the form of y is equal to ax squared plus bx plus c. Foiling the parentheses, we have x squared plus 3x minus 4x. That makes it -x minus 12. Y is equal to 2x squared minus 2x minus 24. I suggest that you pause this video and try to work out the problems on your own. On the left side of the problem, we're given a vertex. So I'm going to use a vertex form. Y is equal to a times x minus 3 squared minus 2. Remember to negate this answer, -3 must correspond to a +3. Then we know y-intercept is equal to 16, so when x is equal to 0, y is equal to 16. 16 is equal to a times 0 minus 3, that's -3 squared, so that's 9 minus 2. Adding 2 on both sides, we have 18 is equal to 9a. Therefore, a must be 2. Rewriting this equation, we have y is equal to 2 times x minus 3 squared minus 2. On to the right side, we also have a vertex at -4 and 2. So I'm going to be using a vertex form for one more time. Y is equal to a times x plus 4 squared plus 2. This point tells us that when x is equal to -2, y value is equal to 0. So 0 is equal to a -2 plus 4, that's 2. 2 squared is equal to 4, plus 2. Subtracting the 2 on both sides, I have -2 is equal to 4a. Dividing by 4 on both sides, I have -1/2 is equal to a. So rewriting this equation, we have y is equal to -1/2 x plus 4 squared plus 2.